Welcome to this flight into the fascinating world of generative pre-trained transformers, also known as GPTs. Have you ever chatted with Chatgpt and wondered, how does it understand me so well? Or, how can it reply just like a human would? If so, you're in the right place. Today we'll embark on an exciting adventure, breaking down the core aspects of GPT in the simplest terms. We'll guide you step by step, transforming you from a curious beginner into someone who can explain how this amazing technology works. So buckle up and let's get started. GPT stands for Generative Pre-trained Transformer. Let's break that down. Generative, it can produce or generate new content. Pre-trained, it's already been trained on a vast amount of data before you even interact with it. Transformer. This refers to the specific architecture that allows it to understand context and relationships in language. Let's explore how a transformer model, like GPT, understands questions and generates answers. Let's ask GPT, what creates tears? First, GPT processes each word in the question, what creates tears? In this sentence, the word tears can have multiple meanings. It can mean tear, as in, there is a tear in my dress, or tear, I was sad and cried a tear. So GPT has to firstly work out which meaning of the word tear to use in your question. Imagine GPT as the world's busiest, smartest airport. In this airport, words are passengers, and GPT organizes words to travel on planes with other words. Just like an airport efficiently manages the flow of passengers based on the order they enter the airport, GPT creates tickets for your words and puts them on different flights. All are going to the same destination, but via different airports. All the words get on their planes, and the GPT flights take off. On one flight, your question words are surrounded by passengers returning from Fashion Week. Passengers talk about fashion, so your words think about fashion as well. On this flight, tears means tears, as in tears a piece of fabric. On another GPT flight, your question words are surrounded by passengers returning from an optometrist's convention. The optometrists talk about eyes and glasses, and so your group of words on this flight begin to think about eyes as well. On this flight, tears means tears, as in tears when you cry. GPT pays attention to these in-flight conversations and what other words are on the planes. When the GPT planes land at a first airport, GPT feeds information back from each flight and thinks about where words should sit on the next flight. As the GPT planes stop at the next airport, other GPT word passengers get on the planes. As new passengers join a flight, the knowledge on each GPT plane is constantly changing. This moving of word passengers around in the plane and even rerouting them on a different flight is how GPT starts to come up with the right meanings for you. GPT needs to work out which words should sit next to your question words. When the passengers next exit their planes, GPT will assemble the words all together in the arrival hall. GPT creates tickets for some passengers, so they sit together on the next flights, as word meanings are mixed together. GPT is getting closer to creating a response to your question. Do you recall us asking that first question, what creates tears? Here we are, in the middle of how generative pre-trained transformers work. This is an epic journey. You might be starting to see that on this trip, our question words are the passengers, vectors are the tickets, the planes are embeddings, the airports are the neural network layers. GPT feeds the results of processing any one vector back into processing the next vector, thereby keeping the context of the previous vector, and so growing the meaning as a whole as the process continues forward from layer to layer. The various airports Air GPT might visit en route are like the layers of the GPT neural network. Each airport can mix passengers up so they are closer and more aligned with other passengers. First, each word in the sentence, including tier, is converted into an embedding, a numerical vector that captures its possible meanings based on the model's learned knowledge. Next, the transformer uses the self-attention mechanism to examine relationships between tier and all other words in the sentence. This mechanism allows the model to weigh the importance of each word in understanding the context. The model calculates attention scores to determine which words are most relevant to interpreting tier. In this case, words like noticed and dress receive higher attention scores. Through this process, the transformer effectively disambiguates the word tier, selecting the meaning that best fits the context of the sentence. This is how the transformer model processes a word with multiple meanings by exploring all possible interpretations and using context to pinpoint the most appropriate one. The self-attention mechanism is key here, enabling the model to consider the importance of each surrounding word in understanding the target word. GPT's transformer architecture allows the model to pay attention to different parts of the input data simultaneously. It's like the GPT flight tower is able to communicate with multiple planes at once, coordinating to gather the most relevant passenger information from flights. Like air travel today, the GPT model represents a significant advancements in processing and generating language over traditional neural networks. Generative pre-trained transformers can capture complex relationships and maintain context over long sequences, much like passengers gaining diverse experiences and knowledge throughout a dynamic travel itinerary. GPT models deliver a deeper and more connected understanding of language, enabling them to generate responses that are coherent, contextually relevant, and rich in information. The words in your question are passengers. The planes are vector groups, and airports are layers in the GPT model. Air GPT uses advanced ticketing and scheduling to ensure the words are grouped together and arrive at the right destination. How does GPT become so knowledgeable and capable? It all starts with a massive training journey. Picture our airport at the beginning, small, with just a few flights and passengers. But over time, as it handles more flights and processes more passengers, it expands and becomes more sophisticated. Similarly, GPT is trained on an enormous amount of text data from the internet, like having read every book in a vast library. This training helps it understand grammar, facts about the world, and even some reasoning skills. Let's see how GPT processes your input and generates a response. You provide a prompt, the traveler's question. This is the starting point for the model to generate a response. The model then encodes this prompt into a form it can understand, much like the staff translating the question into an internal language of symbols and codes that represent different pieces of information. GPT processes this encoded information, analysing the context and meaning. It considers all the relevant knowledge it has acquired during training, much like the staff member drawing on their training and resources to find the best answer. The model generates a response by predicting the most appropriate next word, one after another, until the full reply is formed. Finally, the model decodes the response into human language and presents it to you. Just like the staff member communicates the directions back to the traveller in a friendly and understandable way. So, what makes GPT-4's transformer architecture special? Think of it as a network of airports working together seamlessly rather than a single airport handling all flights. Let's delve deeper into how this transformer changes the game. The transformer uses something called an attention mechanism. This allows the model to focus on the most relevant parts of the input. It's like airport staff paying extra attention to passengers with special needs or urgent flights. Unlike previous models that processed information step by step, transformers can handle multiple pieces of information at the same time. This parallel processing is like air traffic controllers managing several flights concurrently, making the whole system faster and more efficient. This architecture allows GPT to understand context over long distances in text. It's as if the airport staff can connect a passenger's journey from their origin to their final destination, even if it involves multiple transfers and airlines. They see the big picture, ensuring everything fits together smoothly. To make the most out of GPT, here are some handy tips to help you get better responses. Provide clear and specific prompts. Instead of asking, "Tell me about animals," try, "Explain the migratory patterns of Arctic terns." The more specific you are, the better GPT can tailor its response to your needs. Give context if needed. For example, as a nutritionist, explain the benefits of a balanced diet. By setting the context, you help the model understand the perspective or angle you're interested in. If you need information in a certain format, ask for it. Like, provide a bullet point list of the top 5 tourist attractions in Paris. This helps GPT present information in a way that's most useful to you. If the response isn't perfect, refine your question or ask for more details. Don't hesitate to follow up with, "Can you expand on that?" or "Could you give me an example?" Congratulations! You've navigated through the world of GPT, from its high-level functions to the intricate details of how it processes language. With this knowledge, you're now equipped to both understand and explain the core aspects of GPT-4. Remember, the next time you interact with an AI language model, you'll know the incredible journey your words take to become a thoughtful response. If you found this video helpful, don't forget to like, subscribe, and share for more tech breakdowns.